Okay, so we will be going to see question number 28 of Go test series 1. It was a free mock test, and this the question is from TOC, and this is a very good and conceptual question. Such kind of question we can expect in upcoming GATE exam. Okay, so let's check out the question. It's a 2 marks question, integer type with 0 negative marking. Okay, let's read the question. Let D be a DFA with 10 states, and let the cardinality of the input alphabet set is 3. Okay, so cardinality is 3. Generally it is 2, but here it is 3. So we have 3 input symbols. Okay, let us assume it as A, B, and C. Okay, then and the language accepted by D, which is a DFA, is a finite language. Okay, finite language means no loop in the DFA. Then the maximum value of the language means, okay, cardinality of the language means maximum number of language we have to find will be, okay, this is the integer type question. Then okay, let's understand that the cardinality of the input alphabet set is 3. Means in a DFA, for every input we have one transition. Okay, if this is the input, then for every input for every symbol, for every input there is one transition. So for A there will be a transition, for B there will be a transition, for C there will be a transition. So for every state Q0 there will be 3 transitions. Okay, now we have to find the maximum number of languages. Here you can see that DFA has 10 states. Okay, so let's assume that it has 10 states and there is no loop. Means we need to have language is also finite, means we have to have a dead state. So let's, first state is our start state, and second state, then third state, and so on. This is our ninth state, and this is our 10th state. So our 10th state would be a dead state, and any symbols come, it will hang into the state. So this is our final state, and the length of the language string is not defined. We have to just find the number of languages. So language can be of length 0 or length 1 or length 2 or length 3 or length, maximum length could be 8. Why 8? 8 because our one state is dead state, and we have a number of state is equal to 9, and with 9 states implies that number of edges would be 9 minus 1 equal to 8 edges. So with 8 edges we can have 3 raised to 8 strings of length 8. Okay, but we don't want a string of length 8, we want all the strings. So the number of strings would be, okay, our initial state is also accepting state. Okay, one length string is also accepting straight, two length string is also accepting straight, one length string is a comma b comma c, two length is a comma b comma c. Then if a or b or c comes at the last string, go to some state, and thereafter there is no coming back. Okay, then so the total number of strings would be of length 0, which is, okay, one string of length 0, and length 1 there would be 3 strings, length 2 there would be 3 raised to 2 strings, length 3 raised to 3, and so on. For length 8 it would be length 3 raised to 8. So you can see that this is a GP. Okay, and you can solve it as 1 plus a into r to power n minus 1 upon r minus 1. Okay, and this is a simple GP formula. So you put the value of a and r, 1 plus 3 into 3 to power, number of strings would be, I am taking this, so 8 terms are there, 3 is to 8 minus 1 upon 3 minus 1 2. So if you calculate it, it comes out to be the answer. Okay, you can do it. Yeah, so this is a very good concept.